finish this sentence in your head. The sky is... You thought blue, didn't you? That tiny thing you just did, predicting the next word, is the entire secret behind ChatGPT, Claude, Gemini, every AI you've ever talked to. They predict the next word. That's the whole trick. And yet somehow, that one simple move turns into something that can write code, pass the bar exam, and argue with you about pizza. So how does guessing the next word become something that feels like it's thinking? Today, we open the box. This is how tech works, where we take the technology running your life and actually open it up. Over 1 billion people now use AI like this every month, and almost none of them know what's really happening when they hit enter. No hype, no math degree, it's basically magic. In the next 10 minutes, you'll understand the 3 ideas inside a large language model, and you'll know exactly when to trust it and when it's confidently lying to your face. Let's get into it. Idea 1. A large language model has exactly one job. Look at some text and guess the most likely next word. Then add that word and guess again and again. That's the whole engine. When you ask ChatGPT a question, it isn't looking up an answer in some giant database. There is no database inside it. It's predicting word by word what a good answer would probably sound like, based on patterns it learned from a staggering amount of human writing. Think of it as autocomplete, the thing on your phone keyboard, but scaled up about 1 million times. Your phone guesses the next word from the last few you typed. A language model guesses having effectively read a huge slice of the entire internet. Same idea, wildly different scale. And that scale is where things get strange. Which brings us to idea 2, the one that makes people go, wait, what? A computer can't actually read the word cat. It doesn't know letters, it doesn't know meaning. So the first thing a language model does is turn every word into numbers. A long list of numbers that works like a set of coordinates, a location in space. Every word gets its own spot. And here's the beautiful part. Words with similar meanings end up sitting near each other. Cat and dog land in the same neighborhood. King and queen are close. Banana is way over in some other district entirely. Nobody tells it to do this. It arranges words this way on its own, just from seeing how we use them. And once words are points in space, something almost magical falls out of it. Meaning gets a direction. Take the location for king, subtract the direction for man, add the direction for woman, and you land almost exactly on queen. Let that sink in. The model learned the idea of royalty and gender and how they combine, not because anyone programmed it, but because those relationships are baked into the way we write. Meaning became math. That's the moment a pile of numbers starts behaving like it understands. But predicting the next word takes more than knowing what words mean. It has to know which words matter right now. Read this. The trophy didn't fit in the suitcase because it was too big. What was too big? The trophy or the suitcase? You knew instantly. The trophy. Now change one word. Because it was too small. Suddenly, it means the suitcase. Same sentence, one word flipped, and the meaning jumps to a different thing. That's the problem a language model has to solve on every single word. The solution is called attention. As the model reads, attention lets each word look back at all the other words and decide which ones to actually focus on. It looks around, weighs the options, and links to the right thing. Do that across a whole paragraph, stack it dozens of layers deep, and the model builds a genuinely rich sense of how everything connects. This is the leap from dumb autocomplete to something that tracks meaning across a whole conversation. Okay, but where did all this come from? Nobody taught the model that king relates to queen or what a trophy is. It taught itself by playing one game trillions of times. The game is fill in the blank. Take a real sentence from the internet, hide the next word, and ask the model to guess. It guesses, badly at first. You show it the real word, and it nudges billions of tiny internal dials, just a hair, to be a little less wrong next time. Now do that trillions of times across books, websites, and code. Slowly, those dials settle into patterns that capture grammar, facts, reasoning, and style. Those dials have a name: parameters. GPT-3 had 175 billion of them. Today's models have far more. And here's the wild part. None of the knowledge is stored as facts you could go read. It only exists as the pattern in those billions of dials. The model didn't memorize the internet. It compressed it. Which explains the single most important thing to know about these tools: why they lie. You've seen it. You ask a confident question and get a confident answer that turns out to be a fake court case, a book that doesn't exist, a statistic it invented. That's called a hallucination. And once you understand the engine, it makes total sense. Remember the one job: predict the most likely next word. Not the most true next word, the most likely sounding one. When the model actually knows something, likely and true line up, and you get a great answer. But when it doesn't know, it doesn't stop. It can't say no result found. That's not how it works. It just generates the most plausible sounding answer anyway, with the exact same confidence. It's not lying to deceive you. It literally can't tell the difference between knowing and guessing. So the rule is simple. Language models are brilliant at things you can check, and risky at things you can't. Trust, but verify. So let's put the whole box back together. A language model turns your words into numbers, so meaning becomes a position in space. Attention lets it figure out which words matter, so it tracks context. Years of fill-in-the-blank training tuned billions of dials, so it absorbed the patterns of human language. And then it does the one job: predict the next word, over and over and over, building its answer one piece at a time. That's it. That's ChatGPT. That's every model from OpenAI, Anthropic, Google, and Meta. No magic, no mind, just 3 stacked ideas and an astonishing amount of practice. And that's the honest version. A large language model is one of the most powerful tools humans have ever built, and it is not thinking, not conscious, and doesn't actually know anything the way you do. It's pattern prediction at a scale that's hard to imagine. Powerful and not a mind, both true at once. If this finally made AI make sense, subscribe, because next we open an even weirder box. What's actually happening inside the chip the moment you hit enter, and why it costs a fortune to run. See you there.